In this video, we'll look at domain, range, and translations of exponential graphs. And we'll start with the function f of x equals 2 to the x. So to graph this function, we could make an xy table. We could use the points -2, -1, 0, 1, 2, and let's also use 3. And plugging those x values into the function, 2 to the -2 would be 1 over 2 to the 2, or 1/4. 2 to the -1 would be 1/2. 2 to the 0 is 1. 2 to the 1 is 2. And 2 to the 2 is 4. 2 to the 3 is 8. And if we plot those points, we get this graph. Now, a few things to notice about this graph: it has an asymptote at the x-axis. So at y equals 0, and that asymptote affects the range. So the graph approaches the line y equals 0 as x goes towards -infinity. So the range is y greater than 0, or the interval from 0 to infinity. And the domain is -infinity to infinity. We can plug any x value into this function. So another way to say that is that x is an element of the real numbers. So now if we look at a translation of this graph, 2 to the x plus 3 for g of x, that means that for the same x values, so -2, -1, 0, 1, 2, and 3, the y values will be the same except increased by 3. So -2 and 3 and 1/4, -1 and 3.5, 0 and 4, 1 and 5, 2 and 7, and 3 and 11. So these were obtained by taking the y values of 2 to the x and then adding 3 to them. Now let's plot these points, -2 and 3.25, -1, 3.5, 0, 4, 1, 5, 2, 7, and 3, 11. And this creates the graph for 2 to the x plus 3. We can see a couple things from this graph. The asymptote is now at y equals 3. So it was at y equals 0. It got shifted up 3 because of the plus 3 in the function. The range then is y greater than 3, or the interval from 3 to infinity, and the domain is still -infinity to +infinity. So adding or subtracting a number at the end of the function, like this plus 3, causes all of the y values to increase by 3, so it moves the asymptote, and it also moves the range from 0 to 3. So for this next function, 2 to the x minus 5, we could again make an xy table, or now we could see that's just going to shift the y values down by 5. So if we take each y value on the original 2 to the x function that's drawn in black, we can shift all those down 5. So take this point, move it down 5 to -4. Take this point, move it down 5 to -3. Take this point at 2, 4, move it down 5. And just continue for each point. And again, you could make a xy table if you would like. So now the asymptote is at y equals -5. And the domain is all of the values above -5, so the interval from -5 to infinity. The domain is still -infinity to +infinity. So the range is shifted up down to -5 from 0 for the original function. So again, whatever this end number is that is added or subtracted from the function moves the asymptote and thus moves the range. Now let's look at horizontal translations. Now horizontal translations are caused by a change in the exponent. So for example, if you look at g of x and h of x, the x plus 3 and the x minus 5 are in the exponent, whereas with the vertical translations, the plus 3 and the minus 5 were after the base with the exponent. So added or subtracted from the end of the function. So let's again start with an xy table. So for the values -2, -1, 0, 1, and 2 to get an accurate graph of 2 to the x. And then we'll plot 2 to the x. Okay, so asymptote is at y equals 0. So the range is 0 to infinity. The domain is -infinity to infinity. So now let's look at what happens if we add 3 in the exponent. So let's look at the same points, -2, -1, 0, 1, and 2. So now if we plug in -2 for x, we get 2 to the -2 plus 3, so 2 to the 1, which is 2. If we plug in -1, we get 2 to the 2, which is 4. So -1, 4. And if we plug in 0, we get 2 to the 3, which is 8. So now actually, instead of plugging in the points at 1 and 2, we'll go off of our graph. Let's plug in a few points to the negative instead. So -3 and -4. So plugging in -3, we'd get 2 to the 0, which is 1. So -3, 1. And plugging in -4, we would get 2 to the -1, which is 1/2. And now we can sketch the graph. So the asymptote is still at y equals 0. The range is still 0 to infinity. And the domain is -infinity to infinity. So the asymptote, domain, and range do not change for a horizontal shift. But one important thing to notice is that the graph shifted to the left 3 units. If we look at each of the points, so at the point 2, 4 on the original graph, that point is moved to the left 3. So adding 3 in the exponent causes a horizontal shift to the left 3. So adding causes a shift to the left. That means that subtracting, so subtracting 5 as in h of x, should cause a shift to the right. So we can take each point, we could make an xy table, or we can just take each point from the original function, which is drawn in black, and shift it to the right 5. So 2, 4 becomes 7, 4. 1, 2 becomes 6, 2. 0, 1 becomes 5, 1. And we can draw the rest of the graph from there. So again, the asymptote does not change. It's at y equals 0. The range is from 0 to infinity, and the domain is negative infinity to infinity. Let's summarize these translations. So if our original function is just a to the x, where a is some number greater than 0, then that would mean that the domain of that function is negative infinity to infinity. The range is 0 to infinity, and the asymptote is at y equals 0. So if we add a number, so if we look at a function a to the x plus k, where k is positive, that's going to shift up k units. And it will change the domain, or the domain will stay the same, negative infinity to infinity. But it will change the range to k, comma infinity. If we subtract a positive number from the function a to the x, so if we look at a to the x minus k, where k is positive, that would cause a shift down k units. Domain would be the same, negative infinity to infinity, and the range would be negative k to infinity, with an asymptote at y equals negative k. So that's if we add or subtract a constant number at the end of a function. If we look at the function y equals a to the x plus a constant c, that's going to cause a shift to the left c units, and the domain and range stay the same as the original. So the domain will be negative infinity to infinity, and the range will be 0 to infinity. And then the last change, if we subtract a positive number in the exponent, so y equals a to the x minus c, where c is a constant in the exponent, that will shift the function to the right c units. And again, the domain and range will stay the same as the original for a shift to the left or the right.